Good morning friends, and in this video we are going to discuss about the electric dipole, the electric field due to a electric dipole. Now what is an electric dipole? So in the previous video also we have discussed, again I can discuss that it is just two equal and opposite charges separated by a tiny distance, and that is your dipole. So you can take your dipole something like this is minus q and this is plus q. So two charges minus q and the plus q separated by a distance d, and then we have idea of electric dipole moment, that is q times d bar, and direction is from minus to plus, means you can say in this direction. So since this is the electric dipole, it can be placed this way or that way, but we are interested right now in finding out that electric field when a point is placed on its axis and from its midpoint r unit away. So this is the midpoint. So here I can say that we are interested in finding the electric dipole at the point here, and now yes, so you can say this is my point P where I am interested in finding out the electric dipole, and this distance from here to here, this distance is r. Now you know that since I have taken this quantity as d, so just for sake of convenience, if we assume that this distance d is not just d but 2a, then this length will become 2a. Why 2a? Because I don't want to deal with fractions, so that this part is a and this part is also a, and the dipole moment will become 2a cube, just like this. Magnitude will be doubled and this d will become a. So now here we are interested in finding, so we will be using the idea of the principle of superposition, that is electric field at this point due to this minus charge, that is E of minus q, and that we can use first. Let me change my color. So electric field minus q means electric field at P due to this minus q is 1 upon 4 pi epsilon naught q upon, now from here to here this distance is r and this is a, so it is r plus a whole square, and the direction will be towards this, means in this direction, that is E of minus q, because we consider that we are placing a unit positive charge here. So this charge is positive and this is negative, so that charge will be attracted in this direction. Now since this charge, again, this is also called test charge, this is how the electric field concept electrostatic has been generalized. So now you'd say that if I find out the electric field at P due to this plus q, then this will be given as E plus q is 1 over 4 pi epsilon naught q over, now this distance is r, and from here to here, like this distance is a and this distance is r. So what is this distance? That is r minus a. So r minus a whole square, and this will be in this direction. Now we have to find, just look at nicely at the diagram. So we have this because only these two charges are there. So we find the total electric field, just like finding the principle of superposition, applying the idea of the principle of superposition. We have to find the value of E, and that will be E sum of these two. So our E will become E of minus Q plus E of plus Q. Now without wasting time, if you see, if I have to add these two, so I see Q upon 4 pi epsilon naught is common. So I just take Q upon 4 pi epsilon naught common, and there I'll get 1 upon R plus A whole square plus 1 upon R minus A whole square. So this is Q over 4 pi epsilon naught. You'll get R square minus A square whole square. This is the product of these two, because we are assuming these two numbers as the co-prime numbers and their LCM will be just the product of these two. So on the top you'll get R minus A whole square plus R plus A whole square. So Q over 4 pi epsilon naught. A plus B whole square plus A minus B whole square is 2 times A square and B square. But here we have to pay one attention that these two forces, because E plus Q is positive because it is on the right side, so E minus Q should be negative when you are adding this. So E minus Q means this quantity should be negative, so this will be negative. Okay, so now you see we are getting A plus B whole square minus A minus B whole square, and this will give you 4AB, that is 4RA upon R square minus A square whole square. So if you just assume that R is much bigger than the distance of separation, like if you say that R is much bigger than A, then this quantity will become Q over 4 pi epsilon naught 4RA. If I take R square common, this will become R to the power 4 minus 1 over A square R square. So A square upon R square will be so small that we can ignore it. So we are taking it's kind of 0 or close to 0. Then our expression E will become Q over 4 pi epsilon naught 4RA upon R to the power 4. Now just look at this 2AQ. So 2AQ will be our dipole, that we can write P. So here 2 means then you have 2PR, and this R will cancel this R, so I cancel this, and better I write here 2P upon RQ, and here we have 1 upon 4 pi epsilon naught E. So this is the idea of the electric field you have found, and E equal to is coming positive means effectively it will be acting in the positive direction of x-axis. So this is our idea that E will be so here I can write it as vector quantity, and this is our derivation. So again, this derivation is true when the electric field we are trying to find out is along the axis of dipole and R unit away from the midpoint of the dipole. I hope that you understood this concept very well, and in the next video we'll try to place the electric dipole in some other form, so that we can find how far on the equatorial plane, I mean to say that this is just like perpendicular and there. So just let me clear the screen, so I come back to you. Just give me a 15-second break. Now if the dipole is placed in this fashion, like this is plus q and this is minus q, and then the direction, as you all know, is always from negative to positive. So again, in the same case, I'll assume that length of this dipole is 2l. Don't be slave of the symbol. It can be anything. Why we are taking an even number? So that when you halve it, then you can just get a. Instead, if I take it as d, then I'll get d upon 2. Then I have to deal with the fractions. Finally, the result will be same, but you will have just one fraction. So do not get confused. That's why it has been simplified already by taking this assumption. And then on its equatorial plane, on its equator is just on a line perpendicular bisector to the axis, we have to take a point P there, and we are interested in finding the electric field at this point due to this, and then we use the principle of superposition to find the relation. So this one goes like this, and here also this goes like this. Okay, so now here we are interested in finding the electric field due to this. So we'll assume a test charge will be placed here, and the distance of this is r. So this distance from the equator, this distance is a, and this is small a, and this is small a. So now you can understand that this is going to be r square plus a square to the power half. So that is the distance what we are going to use, because this is the distance from both, because this is an isosceles triangle. So this distance will also be this. Now I am trying to find out the electric field at P due to this. I am staying away from the screen so that you can have the more exposure to the screen rather than to my face, because this is more important than my face. So this is plus Q and this is P. So the electric field, suppose if I take a unit test charge here, so this is positive unit test charge and this is also positive. So here the field will be working in this direction, and that is E plus Q. Same way here, if we place a unit positive charge, then it will be attracted. So electric minus Q, this one will be placed there, and then we have to find their resultants. We'll have to resolve these two forces, and then we have to add them factorially to find their resultant. So now what happened, that first let me find this quantity, that is E due to plus Q is 1 over 4 pi epsilon naught, and then Q upon R square plus A square, and that is whole square. So this will become just R square plus A square. And yes, so here you see that this is also by the symmetry, this R square, this is going to be R square plus A square and half. So the electric field at P due to this positive Q is plus Q, 1 upon 4 pi epsilon naught, Q upon R square plus A square, and this is the direction of that one. Same way electric field, electric field due to minus Q is 1 over 4 pi epsilon naught Q over R square plus a square, and this will be in this direction because this is unit positive charge and this charge will be attracted by this negative in that direction. Now we have to find the vector sum of these two forces. So just for sake of simplicity, if I draw a grid here so that we can understand their components properly, this is going in the direction like this. I can assume this angle to be theta, it's fine. Now here when you're trying to find out the component of this along this direction, so this can be written as E plus Q cos theta, and then the component of this downward will be E plus Q sin theta. Now the component of this along this horizontally, it will be in this direction, that will be E minus Q x, that will be cos theta again, and downward it will be E plus Q sin theta. Now if you see the diagram, then what do you see, that this cos theta and this cos theta, these two cancel each other, and then these vertical ones, they simply add up. But since both are going downward, this is also downward, this is also downward, so their resultant component will be E equals minus E plus Q sin theta plus E minus Q sin theta. So E equals minus 1 by 4 pi epsilon naught Q over R square plus A square. This I write like this, and this is minus 1 over 4 pi epsilon naught Q over R square plus A square. This should be minus plus, and then you have sine theta. So here I have, now you see these two just becomes double, so and they are same thing. So 1 by 4 pi epsilon naught 2q upon R square plus A square. Now what is sine theta? I have assumed that this is my theta. So in this case my sine theta will be opposite upon hypotenuse, that is A upon R square plus A square, that is A upon R square plus A square to the power half, because opposite upon hypotenuse. Okay, so then what I'll get, that minus 1 by 4 pi epsilon naught, this 2a into q, this is 2aq, that is my p bar, upon this will become R square plus A square to the power 3 by 2. And what about this negative sign? What does this negative sign indicate? That the resultant electric field is downward, is acting here downward. So this is the idea of the electric field. Now again, if you are interested in saying that like if the R is quite great compared to A, so A upon R will be very very small, so we can ignore it. So here I'll write minus 1 over 4 pi epsilon naught, this is P bar, and this r square will become just r cube, and this is your electric field. The resultant electric field due to this dipole on a point on the equatorial plane or on the equator of the dipole. This is called the point on the equatorial plane, and there you get E equal to minus 1 upon 4 pi epsilon naught P bar upon R cube. If you want to change it, then you can write E bar equal to minus 1 by 4 pi epsilon naught. Then P bar is nothing but 2QA. So you can write 2QA upon R cube, and for sense of direction you can provide P cap. P cap means direction, that is the direction of the, this is direction of the P bar from minus to up, and when you write P cap means you divide P bar by its magnitude, so this becomes just unit vector, and this is negative means the field is downward, because electric field, the resultant electric field is in this direction, and the direction of the dipole is this. That's why you are getting this negative sign. I hope that you understood it well, and it is very simple because it involves the idea of the vector. So thank you very much. Just subscribe to our channel and keep growing with us.